We at Department of Experimental Medicine and Biotechnology are conducting this oration every year to commemorate our esteemed late Professor R.N. Chakravarti, whose vision was to inculcate scientific aptitude in our future generations. Now I invite Professor Dibyajyoti Banerjee, Head of Department of Experimental Medicine and Biotechnology, to kindly officially welcome us all.
It's my great honor to welcome you all today, dear friends. So, formally, to say, I welcome the orator of the day, Professor Pranav De, Dr. Sanjay Jain, our Dean Research, Dr. B.R. Mittal, Sub-Dean Research, esteemed senior professors, retired professors, all the teachers, Madhukullar ma'am, Veena ma'am, our great friends and our seniors, all the esteemed teachers, esteemed guests, students, staffs and friends. So I welcome you all in this prestigious R.N. Chakravarti Memorial, Professor R.N. Chakravarti Memorial Oration, and I thank you all for your gracious presence. Thank you.
I now request Ms. Parul to kindly present a bouquet to our orator, Professor Pranab De, Director of Pathology and Transfusion Medicine, NIMR, Jaipur. I now request Ms. Neha to kindly present a bouquet to Professor Sanjay Jain, Dean Research, PGI. I now request Ms. Priyanshi to kindly present a bouquet to Professor B.R. Mittal, Sub-Dean Academics and Research, PGI. Thank you so much. May I now invite all the dignitaries to kindly light the lamp and start the function with the blessing of Goddess Saraswati Ma.
या श्वेत पद्मासना या ब्रह्माच्युत शंकर प्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती शेषजाड्यापहा शुक्लां ब्रह्म विचारसार परमाम् आद्यां जगत्.
Now I request Professor Sanjay Jain, sir, to kindly say a few words in Professor R.N. Chakravarti's honor and about this oration, sir. Sir, please.
Thank you and good afternoon, ladies and gentlemen. It's my great privilege and honor to extend a warm welcome to all of you to this prestigious oration, which is Dr. R.N. Chakravarti's oration. As usual, we are always delighted to host this gathering of distinguished clinicians, researchers, faculty members, students, and esteemed guests, because all of us are united by a common theme. How can we improve upon patient care to provide the best to the most underprivileged section of our society? Today's oration actually is a dedication to all of them, because through these orations only we foster our knowledge, innovation, and excellence in healthcare. Over the years, this platform actually has been graced by many luminaries who have shaped the course of medicine. Now let me speak a few words about the orator today. Orator, Professor Pranab De, is my literally batchmate. He was only 6 months senior to me. And we shared the same cannon block. I used to stay in 547 and he was staying in 339. I stayed for about 3 years and he stayed for 10 years. Let me tell you that he overstayed and he was fined by PGI. Is that true, Pranab? Yes. So that's a fact, but we shared many common moments. There used to be a canteen which was called Taj Bengal. That was on the top of the 5th floor. So most of the doctors from Bengal used to have fish and they will have fight every day that who's getting the bigger part. So that's what PGI was in 1980s. But to tell you the story, Professor R.N. Chakravarti has been, I would say, a founder of this great institute. He was one of the pillars, and I don't think I can say anything because I only heard about him through Professor Ganguly, Professor Majumdar. All of us were in such great awe that, there were hardly any words which could not be said about him. These are those people who can actually never be forgotten. But as it is customary, I will just read out few words which have been handed over to me. And it just suffices to say that he was the one who laid the foundation of this great department of experimental medicine and biotechnology. And I can believe me that 85% of the research which used to occur at PGI originated from this department. He was the one who laid many fuss, which included courses in biotechnology, for the students, for the researchers. Personally, he was very much interested in the field of atherosclerosis, and his innovations, his research articles are even quoted today after 40 to 50 years. He was the one who actually brought many laurels to this institute. And more importantly, the two great characters he had was discipline and integrity. People could take oath on him, and he was the one, for whom I believe my words would not be enough. I think I would stop here, and I would wish you all the best, and possibly only pray and hope that we carry on his legacy. Thank you very much.
Thank you, sir, for such a wonderful introduction to a great legend, Professor R.N. Chakravarti, and sharing moments with Professor Pranab Dey. Now, I request the head of the department, Professor Dibajyoti Banerjee, to kindly introduce Professor Pranab Dey, the orator of our day.
Actually, Professor Pranab Dey doesn't require any introduction in this institute. It's his institute. Actually, he can introduce many of us on many things of this institute, but it is customary that I should introduce him. It's actually my honor to introduce a person like him. Now, at first I want to say that we have called one of our professors by seeing one thing, that he is, while working in PGI, he is enlisted as one of the top 2 scientists of the world by independent academician group who has published an academic bulletin without any of the included person's application. And Barda, etc. that I have pasted, that's okay. That many people have, but he's selected. Now the issue is why? Now, so this is the book coverage of the From Earth to Moon. Jules Verne thought in 1876, and this is the laughter of Neil Armstrong after coming back from moon, 1967, 93 years. So everybody thought 93 years before that somebody will go to moon. And here what has happened, very humble article in 2002 has been published in Indian Journal of Pathology and Microbiology by 2 authors. I expected the other author, I expected the other author, the contribution is actually whole life, but in other papers is not there. But it's artificial neural network, inductive logic, holistic approach, and this is biology, deductive logic, and at that time separation science. One thing, one cell, one protein. So it's just the opposite thing. And very, one picture of a neural network and neuron, a 3-page article. And then what is to be put in the neural network? Next one, fractal geometry, a mathematics topic in pathology. Now the fruit of these two, I think this is the first one, if I am not wrong. And then continuous thereafter. Today it has reached 642 citations per year. And this is the talk of the day. This is the way both the biological science and the physical science and all science, social sciences in a holistic, systemic way, which is together known as data science, that the way everything is thought of. Now the second fruit, textbook, it is its second edition, and not one. Google Read gives continuous. So from this author, an eminent scientist, we will hear his story, rather the story of the subject, development of the subject, not only pathology, the whole biology, at least our subject as a data science course today, goes in this way. So these words are customary, everybody knows. This is for the students here. Other people know it here. Thank you very much.
I now request Professor Parnabde to kindly deliver the oration. Sir, please.
Good afternoon, and my thanks to Dr. Dibojyoti, Head of the Experimental Medicine, Dr. Sanjay Jain, Dr. Mittal, Dr. Das, and all the dignitaries. And dear friends, first I wish to express my regards to Dr. R.N. Chakravarti. I have the opportunity to meet him in my early days in PGI. He was the great visionary and researcher. Today, my topic is a tale of computer application in the health science. And this is the overall subtopic. What is a tale or story? A story is nothing but data entangled with the soul, and the soul is the person's soul who is speaking. So my data will be to some extent personalized. Our story started long back. In the year 1901, near the island of Antikythera, this is one of the Greek islands, the diver salvaged the shipwrecked elements. What was the ship which was drowned? It was about 2,100 years back. The ship was going from Rhode Island to Rome with the gift of the great Julius Caesar for his birthday gift. And it was full of jewelries, pots, and many articles. Along with that, the divers recovered this element, which was neglected for years and years. In the year 2008, almost more than 100 years, the scientists did the tomographic examination, and they came to know that it is the rarest elements in the earth. What was that? It was nothing but a computer, analog computer, which can predict the astronomical position and eclipse decades advance. So this was the first computer, and our story begins with that computer. When I was child, one day in the primary school, our teacher told us that we will have a next institution visit. What was that institution? Indian Statistical Institution. And she said that there is an instrument which can draw the picture, can give all of your answers, and incredibly fast can do the calculation. When we went there, we saw the whole room is filled up with the instrument, and that was the computer. We thought that when we will have this computer in our home or in our desk, just within few decades, it appeared. In 1971 onwards, microprocessor-based computer came into field, and it was the now smallest computer. And this is the overall graphical presentation of the how computer will help us in the health science. All of us who are elderly people, more than 50 years, have the experience of the world without computer. World without computer is nothing but paper, pen and pencil. But gone are the days of handwritten patient records, slow diagnostic process and guesswork. That is over. If data is the lifeblood, then electronic health record is the main component of it. And it improves the accessibility of the data, it reduces the error, and electronic health record does streamlined processing of the data. Along with that, I have to say that health information system, it is very important because it accumulates patients' demographic data, medical history, laboratory result, medication list and treatment plan. And it is very important for patient scheduling, billing and management. Now, we started our journey in the year 1995. At the time, there was no substantial work on automated morphometry in the Asian and Indian subcontinent. And this is our image analyzer. You can see the CPU that is 3 feet by 2 feet, but hardly 100 megabytes memory. And that was the oldest computer in the department which we used. And the basic principle is very simple. Adjusting the gray value of the nucleus, we detect the nuclei or cell of interest, and then we extract the feature. And we worked on the breast carcinoma, different lesions to identification, grading of the breast carcinoma, prognosis of the breast carcinoma with the help of image morphometry. And in the urinary system, we identified benign, atypical and malignant cells. In the effusion cytology, we did number of diagnosed dots, area of diagnosed dots, and also fusion reaction is the DNA specific stain. So by measuring the optical density of the fusion stained nuclei, we assess the relative DNA content of the nucleus. So we worked on the ploidy analysis by examining the fusion stained slides. And quantitation of the immunostained material also done by this morphometric machine. And this was our position in 1995. And this was the applications we have done with the help of image morphometry. At the time, the Mandelbrot and his world of fractal geometry, as Dr. Dibojyoti was mentioning, fractal geometry works on the self-similarity. And he published his work in Science magazine long back. He said that clouds are not spheres, mountains are not the cones, coastline are not circular, and even the lightning is not in the straight line. We all know about Euclidean dimension. Euclid, the famous geometrician, the teacher of Alexander the Great, he established his Euclidean geometry, and that he said that line has one dimension, square has two dimensions, and cube has three dimensions. We all know. But in fractal geometry, there is fractal dimension. That means if the line is zigzag way and fills up the whole space, the one dimension line will be two dimension. So in between the zigzag line, we'll have the fractal dimension. And the best example is the Cox curve, which is a line has 1.2 fractal dimension. So with the help of fractal dimension, you can measure the irregularities of the object. And as the malignant cells have irregular outline, so it may help in the detection of malignant cells. So we worked on fractal geometry in the year 2003. And with the help of fractal dimension measurement, we identified benign and malignant cells in the breast, in the cervical smear, low-grade squamous interepithelial lesion, LC, high-grade squamous interepithelial lesions, in the urine, benign and malignant cells, and so on. And also, we did the pattern recognition, chromatin pattern recognition with the help of fractal dimension. And it was very much important to differentiate normal, low-grade seal and high-grade seals. And also we used follicular adenoma and follicular carcinoma differentiation with the help of fractal dimension. And this is the summary of our work on fractal dimension. And we thought that fractal geometry will be immensely helpful in disease identification, characterization, and understanding the pathogenesis. But simultaneously, in another parallel universe, somebody was working. What he was doing? It is Alan Turing in 1950, the great mathematician. He is not the father of artificial intelligence. He is the mother of artificial intelligence also. He is the main person of artificial intelligence. This great mathematician was punished by the British judiciary system because he was gay. He took cyanide apple with potassium cyanide and he died. And that was the end of his life, but his work was very significant. He thought, can mathematical formula and algorithm generates intelligent system or not? And that was his main work. And artificial intelligence, if you say the first revolution in pathology is immunocytochemistry, molecular biology is the second revolution, then the third revolution is digital pathology and artificial intelligence. And artificial intelligence actually covers machine learning, deep learning, and artificial neural network. What is machine learning? Machine learning has system automatically learns and improves from experience. So more and more experiences, the system changes itself. And that is very important thing. And deep learning, a subset of deep learning is convolutional neural network or CNN, and it uses complex algorithm and artificial neural network. So instead of biological neurons, here there are nodes. And these nodes gets information. by input, and then this calculation is there. I will not go in details, but if the overall weightage of the information is exceeding certain value, then it fires the next node. And this is the multi-layer perceptron architecture. Here the input nodes, then hidden nodes, which is also known as the black box. It solves the nonlinear problem, and then output nodes. This is a very basic of artificial neural network. So we started our work at 2007 onwards. And mainly I used back propagation artificial neural network, and later on convolutional neural network, which is one of the part of deep neural network. So we collected the data, divided the data into training set, validation set, and test set, and then designed the artificial neural network architecture. We trained the neural network, and then we tested on the known and unknown sample. And we made the model on the breast that time to differentiate benign and malignancy, and benign ductal carcinoma, lobular carcinoma. In effusion cytology, we make a model which can detect malignant cells in the effusion cytology. In urine, we worked to diagnose low-grade urothelial cell carcinoma and high-grade urothelial cell carcinoma. In thyroid, we took the challenge. We took the follicular adenoma and follicular carcinoma differentiation, and successfully our model distinguished all cases of follicular adenoma and carcinoma. And recently we did another ANN model which successfully distinguished benign and malignant outcome of category 3 Bethesda lesions, which is very difficult on cytology. We worked also in endometrial cytology, salivary gland, and in the chronic myeloid leukemia, based on clinical, hematologic, and morphometric data, our ANN successfully predicted which will go for early relapse, which will be late relapse. And this is our applications in cytology. What challenges we faced? That time, we faced many challenges. First thing is that it took long time to extract the morphometric data. And you need expedition to extract the data. And the data selection is the manual to some extent, and it is open biased. So how to avoid that things? That time, there was no deep convolutional neural network. It came later on, and it is the powerful solution because here the computer itself identifies the cell of interest. You give the training and give the image, and computer itself will say which will be the malignant cells, which is benign cells. So you have not to extract the data. So data extraction is done by the computer itself. And convolution, ReLU or rectified linear unit activation, and pooling. This three function goes on repeatedly. You can see that one of our case where it reduces the dimension of the data. So it reduces the data dimensions. And then we make the artificial neural network on the reduced data. And our experience is that we make a model of deep neural network which successfully identified benign and malignant cells. And the model had 96% accuracy. It worked very rapidly, and it was unbiased. We also worked on cervical smear, YOLO, YOLO, P3 annotation toolkit we used to identify different lesions in cervical smears with the help of deep neural network. I must mention about the chameleon grand challenge. What was that? In 2016, there was an announcement, a competition, and that competition, it was invited to all the companies which are involved with neural network to identify the metastasis in the sentinel lymph node. And it was seen that the convolutional neural network, it's a part of deep neural network, which supervised learning, it can detect the foci of metastasis. And it has equal expert, it was, as the most efficient pathologist. It was very rapid, and it improves the metastatic detection rate. And later on, deep neural network was used in various other organs, lung, thyroid, urine cytology, cervix, brain, endometrium. But I must mention one of the study of archives of pathology and lab medicine, where it showed that AI outperforms pathologist in cancer detection. It has very high accuracy. And in one of the study of Nature 2020, where large number, more than 50,000, whole slide imaging of mammogram data was fed into the computer, and AI successfully identified the malignant area, and it repeatedly said the radiologist, this is a malignant area. Radiologist ignored. Later on it proved that that was a malignant area. Similar things have occurred, and it was the Lancet 2020 study. And there also in prostate images, it said that this has something wrong and you should see that area. Pathologists neglected, but it proved later on that that was malignant area. That was the success of AI. So this is the first important applications. AI also helps in mitotic count detection, HER2 scoring. It is very important of therapy of different lesions, particularly breast lesions, and PDL1 scoring also. And now there are commercially available software in the market which will help you to score this very essential immunocytochemistry material, HER2, EGFR, mitotic count, and it can also do the grading. So it will be a great benefit to the pathologist. Can you say from this picture what is the character of the person? Probably it's not possible. Actually, this person is a serial killer and sentenced to death in California. But AI can predict which one will have, out of these two smear, which one will have EGFR mutation. In one of the study, Dr. Nalini Gupta of Psychology Department, PGI, she showed that morphology can predict, but AI also equally with very high efficiency, it can predict by seeing the Papanicola stent smear or simply hematoxylin eosin stent slide. It can say, it can predict that the mutational change, and this is very important in the third world country where people will not be able to afford the mutational changes to study. And also the various papers are there where seeing the just H&E stent image, one can predict that MSI, microsatellite instability, and BRAF mutation. So prediction of molecular genetics from simple H&E stent PAP or PAP stent slides is a very important applications of artificial intelligence. And deep learning based cervical prediction is very important because it can say that out of these all images, this is the highest risk, low risk and lowest risk area. It will say that this patient has this risk of malignancy. And I must mention, a few months before, Harvard Medical School published their work in Nature, and they have developed ChatGPT-like model which can predict very successfully the survival predictions, diagnosis, and treatment guidance of the patient. Similarly, 2020 Lancet study is there, Lancet and Lancet Oncology, that is very high accuracy of 5-year survival rates predicted by AI, just seeing the images only. So, prediction of survival from image analysis is one of the important aspects. Another is big data. Big data is the brain of modern medicine. What is big data? High volume data. Varieties of data in different formats. Value, extraction of the exact value, which is important. Velocity, data is very fast, it is accumulating. And veracity, inconsistency of the data. Only AI can handle this big data. And particularly in the age of next generation sequencing, where huge amount of molecular data is available to the researcher, not only pathologist, researcher, and it helps first data pre-processing and quality control. Variants, it identifies the mutational area by comparing with the reference genome, and pathogenicity predictions from the old accumulated data. Then clinical interpretation of the variants, how it will behave, and then treatment recommendation. So this is very important aspect of next generation sequencing, big data handling and genomic data processing. Data fusion. Data fusion, clinical data, genetic data, whole slide imaging data fused. And it is very important for disease classification, prognostic prediction, better prognostic prediction, and therapy guidance. How? First, it integrates the data and harmonizes the data. Second, feature selection. It selects the most important features from the various variables and reduces the dimension of the data. And then it identifies the pattern recognition. What the pattern is present in these different variables, and then it makes the either decision support system or predictive modeling. And predictive modeling says the disease risk, treatment, survival, and thereby AI gives a new area of the medicine, precision medicine, where it rapidly diagnoses the disease, identify unique therapeutic targets. This unique therapeutic target is very important. It will say that this patient should get this therapy. And then real-time monitoring by liquid biopsy. And then the role of physicians are changing now because of artificial intelligence. And so precision medicine, one of the important aspects. Another important aspect of artificial intelligence is drug discovery. One drug to develop, it takes 1.8 billion US dollar, and it takes a lot of time. How it helps AI? It does the virtual screening, which the chemicals will be effective for this disease. Then it designs the drug. It identifies protein structure prediction, 3D protein structure. And Denis Hassabis got Nobel Prize last year, 2024. He is from the AI DeepMind, and he predicted the 3D structure, Nobel Committee said that it is very important for drug discovery, because by that you can say how the drug will interact with the 3D protein structure and then lead optimization. That means it modifies the chemical so that the drug will be less toxic and high potency. And that is the beauty of AI in drug discovery. Natural language processing. This is very important. We know that computer deals only with numbers, 0 and 1. But hi, how are you? This word computer can process nowadays. That is the natural language processing, very important. It does the text mining, recognize the name, disease name, drugs name, brief summary of the medical journals articles, and sentiment analysis. And it is very important because if we will give you till now all the published research work, they are abstract. So natural language processing is very important. And AI also helps in teaching. It will say that these are the areas you should see. And it will say that what are the differential diagnoses and what are will be the ancillary tests you should do. And then in the laboratory workflow also it is very important. It will identify the out of focus area, stain defects, urgent cases will be flagged by AI. And before you see the slides, it will say that you should do the immunohistochemistry. It can send the request for immunohistochemistry. It screens the malignancy for you, and it already formats your report, and just you have to sign, check, and sign your report. That is a great help. So, education and laboratory workflow. So this is the overall AI in the health science. Is there any roadblock? Yes, definite. What was that? It is the indifference of your colleague and the institution. I have personally faced this problem in this institution where AI was grossly discouraged at the 2010 to 2018 till ChatGPT came. And all of my project was discarded in the waste basket. And that is the great disadvantage of development. And it needs large database. It is not possible from a single institution. Multi-institutional collaboration is very much needed to get the data, to train the AI model, and huge data storage is needed. And that is possible by cloud storage. And whole slide imaging, whole slide scanner it contains huge amount of data. Each slide takes about 2 to 3 gigabyte memory. So it is very difficult to handle. So one solution, we cut the images in small batches, and then we analyze these images. Then again we stitch together. And that is a laborious job. And another thing is very important, data protection. Because multiple institutional data you are handling, if AI does a mistake, who will take the responsibility? Medical legal issue will come. And we do not have any knowledge on the black box. In the hidden layer, what is going on, nobody knows. That is one of the problems. It is known as black box. And these are the limitations of AI. Now, I must mention about the digital age in basic science. Whole slide scanner, it scans the entire image of the slide. And just like the scanning of the paper, it scans the slide. And in your computer, anywhere in the world, you can download the image, and any magnification, you can see any parts of the image. And this is the one example in Italian study. It was a remote area. They sent the slide with the flow cytometric data, immunostain material, and you can report it. Now digital pathology, along with neural network, gives a new branch of pathology, that is the computational pathology. What is that? WSI or whole slide imaging data, clinical data, biomarkers, immunohistochemistry or cytochemistry, and genomic data is gathered together, and then you apply artificial neural network. And it will give you the new branch known as computational pathology, and it is a very important area, and you make the model accordingly by applying artificial neural network. And so that computational pathology, you will have data scientist, engineer, and pathologist. And it is a combined approach, not the pathologist alone. So where are we? We are here, 2025, January 31st. In this, we will quickly apply this computational pathology, I hope. And what next? Quo vadis? Where are we going? That is the question. We must not forget about the quantum mechanics. It is no fantasy. It is the truth. Last year, Nobel Prize was given 2 years before to the quantum scientist on quantum entanglement proved. And quantum superposition is a very interesting phenomenon. You must be knowing that Schrodinger's cat puzzle, a cat can be dead or alive until and unless you see. How can it be possible? The person must be saying nonsense. But it is not. Unlike the ordinary computer, which has a classical bit 0 and 1. In quantum computer, one bit can be 0 and 1 simultaneously, or any number between 0 to 1. And it gives incredible power to the computer. Where the ordinary computer takes million years to solve a problem, quantum computer, millionth of a second, it can solve the problem. So when quantum computer, along with artificial intelligence, quantum neural network will develop. And quantum neural network can solve the cancer pathogenesis, the various diseases which have no treatment, such as Alzheimer's and other diseases. It will say, even it can do photosynthesis. And that is impossible to say from the ordinary computer, but quantum computer will decode all the nature's mystery. But here is the danger. Google declared 52 qubits they have made few years back. IBM 1000 qubit. China we don't know. Maybe they are faster. And once quantum computer with neural network, not only the health science, it can break all the codes, bank codes, all the government organizational codes. And it is a danger. There will be no secret to you. No secret will exist. That's why Elon Musk repeatedly said, AI, one of the biggest threats to humanity. We have to think. Hydrogen gives enough time, turn into you people. It seems nonsense, but it is truth. At the time of Big Bang, there was helium and hydrogen. And billion years takes time to make you people and me. So-called human being, intelligent people. Will AI become conscious and may replace human? Last week, Elon Musk gave one interview in the BBC. He said that there is 20% chance that AI will be conscious before 2040. And who will control AI? Will AI become supreme to human? This is a very, very important question which needs rethinking. And AI supremacy can occur because the development of quantum computer and big data. Human being cannot handle that big data. It is impossible for a human being to handle the big data. And development of the new algorithm. That is the danger of AI also. That algorithm itself changes itself. And more it changes itself. And it becomes very powerful. And it can tell lies also. I have no time, but in fact, some codes which is needed that you are robots or not. AI cannot break the code. So what OpenGI did? It has a person tell that, you tell me the code. The person asked why. He said, I am visually impaired. Nobody told AI to tell the lie. But OpenGI told the lies and break the code. And that is the danger of AI. And then I have to mention the nanotechnology, where computer helps the drug delivery, cancer therapy, and biosensors, highly sensitive biosensors are possible. In another few decades, there will be no computer. There will be multiple biochips, maybe in your toilet, in your working table, in your wall, and all the biochips are linked with the internet. And another biochips will be your contact lens or your spectacles. With the blink of eye, you will be connected with the internet. And these biochips will say, yes, Dr. Day, you have that precancerous condition, please treat. Or you have that problem, you have to treat immediately. 10 years before it will say. And so there will be biochips. There will be no computer. Computer will be just antique. And our story will be finished. And then I must mention about the brain-computer interface. Elon Musk, Neuralink has been sanctioned by FDA to do biochips implantation. What biochips does? It collects the signal from the brain, it processes the signal, and it translates the signal's meaning. And it will be immensely helpful in medical and rehabilitation and what not. So, if you see that in the civilization, we have first steam engine, then electricity, then transistor and computer, and now artificial intelligence. It is very important because all this previously we control those instruments. Now there is a danger that AI can control itself, particularly if it is powerful with quantum computer. And that is one of the danger of AI. I must mention, I am not making you afraid, but it is truth. So this is the summary and conclusion of the lecture. But there is the epilogue of this story. Who will be the author of the next revolution? Or who will be the author of this story? Will it be you, the researcher of the experimental medicine and pathology department, who researches and pushes the boundaries of AI in the medicine? Or will it be you, the physicians, the doctors who embrace the technology to enhance the patient care, or the engineer, hardware engineer and software engineer? Thing is that the future of the healthcare is in the hands of all of us. Let us embrace technology, empower medicine, and transform the lives. And if you see that human civilization takes turn several times, each breakthrough, each innovation, and each discovery add a new chapter of this incredible story, a tale of computer application in the health science. And in future, the younger people will take over the charge. and they will complete this story. This tale of computer application is an unfinished tale, and you are the people, the youngest people, who will complete the story in future. Thank you very much.
Thank you, sir, for such a wonderful, inspiring, and knowledgeable talk. I am sure we all have learned a lot about how computers can be utilized effectively for health science. May I now request Professor Sanjay Jain, Professor B.R. Mittal, Professor Banerjee to kindly honor Professor Day. I now request Professor Mittal to kindly extend a vote of thanks.
So very good afternoon, everyone. Professor Sanjay Jain, Dean Research, Professor Parnab Dey, our own faculty colleague now at Jaipur in National Institute of Medical Science and Research, orator for today's oration. Department of Experimental and Biology, Professor Banerjee, head of the department, other faculty colleagues, former faculty colleagues and current colleagues, ladies and gentlemen. It's my pleasant duty to propose a vote of thanks. At the outset, I must thank Professor Parnab Dey to find out time and be with us in this oration and highlighting the tale of computer application in health sciences. He started wonderfully and completed his talk very beautifully, giving the insights about the computers, how it started, and what is the future we are having. I must thank Professor Sanjay Jain also for being here, finding time from his busy schedule, and whole of the Department of Experimental Medicine, Biology, and of course the family of late Professor R.N. Chakravarti, whose enthusiasm and help initiated this R.N. Chakravarti oration, and I hope this will continue even with the younger generations who will take over the department. And this is a wonderful thing to have orations in the name of our founder fathers of the institute who contributed immensely for the upgrowth and bringing this institute to the present level. I must thank the Department of Telemedicine also for giving the online link and this audiovisual team and all the others who participated today. Thank you one and all for being here. Thanks a lot.
Thank you, sir, for your kind words. Ranjan Chakravarti just told that he is unable to unmute his computer, and he has asked us to convey his thanks for the oration. Sir, we need your permission to conclude the event. Thank you, sir. We conclude this oration